All right, guys, we're going to look at some even and odd functions and also do one more little graph transformation just to make sure you don't forget it. All right, first word is even functions today. Even functions, 2 or 3 ways you can tell. One is if f of x equals f of negative x. And we'll talk about what that means there at the bottom in just 1 second. You can also tell if a function is even by seeing if it's symmetric to the y-axis. If it's symmetric about the y-axis, it's even. Right, this first thing right here, where it says if f of x equals negative x, in like everyday, not exactly perfect math language, but language you can probably understand is this right here. If you plug in negative x for all the x's, and you get the same function that you started with, it's even. In other words, nothing changes when you plug in a negative x. Odd function, something a little different happens. Odd function is when f of negative x equals the opposite of f of x. It means every sign changes. All right, so, or if the graph is symmetric about the origin, and that's kind of a weird kind of symmetry. When something is symmetric about the origin, that means the graph looks the same upside down as it does right side up. That's how you can tell. It's hard to tell sometimes just by looking. Turn your paper, turn your book, whatever upside down. If it looks the same, it's odd. Okay, again, the everyday kind of language. If you plug in negative x and every single sign on the function changes, it's odd. All right, here's a couple of examples. This one right here, this first one is x squared. Notice the exponent's even, which is a hint it might be even. All right, look at the graph. It's a parabola, and if you fold this side of the parabola across the y-axis, you get that side. Okay, it's symmetric. It's symmetric to the y-axis. Look at this one. This is odd. Okay, it's x cubed, which means it's going to be an odd function. Probably that's a hint, by the way. It doesn't always work that way, but it pretty much does. Okay, so look at this. If I take this graph, I don't know why I'm tracing it, but if I take that graph right there and I'm going to turn it upside down, which, well, I can do this. Let me see if I can do that real quick. If I turn it upside down, like that, it looks exactly the same as it did right side up. And that's how you can tell if it's odd. All right, these say determine whether they're odd, even, or because they could be neither. Okay, so the first one, the hint is all the exponents are odd, but here's the algebraic way to tell, if you can't graph it, is to plug in a negative x for the x's. That's what I'm doing right here. If I'm plugging in the negative x's for both x's, because they have odd exponents, they're going to stay negative. So I get this, I get negative x to the fifth minus x, which is exactly the opposite of that, which means it's odd. If that happens, it's odd. Let's look at this one. Now this one has an even exponent. Let's see what happens. Let me change colors so we can keep up with what we're doing here. If I plug in a negative x for that x, because it's a fourth power, it's even, it changes the negative x to positive x, so I get this right here, which is exactly the same thing I started with. And because nothing changed, it's even. Okay, so that's the difference. So if every sign changes, it's odd. If no signs change, it's even. So I got one more. I got a feeling I know what this is going to be. So do the same thing. Plug in a negative x right there. Plug in a negative x right here. And let's just work it out. The first part is going to be negative 2x. The second part, that square, will change that negative to positive, but you still have the minus sign in front, so I get this. Now, this isn't the same as I started with. It's also not every single sign changed. Okay, so that's a neither. That's not odd or even. That's neither. Okay, before we close this video, I wanted to graph one more thing here with all these shifts. So let's go through one more time what all these things are. The 1/2. Remember, that is a vertical. I'm going to put vert, shrink. I'm trying to do a shrink by 1/2. The plus, that's a 1/2, by the way. Not a very good one. Let me fix that a little bit. Sorry about that. Come on now. There we go. The +4 is a shift to be careful here. Remember, it's inside, it's backwards, opposite what you think. Shift right 4. I just said opposite and wrote the wrong thing. Left 4. This is a great slide so far. Shift left 4. And that -3 on the outside is exactly what you think. You would shift, let me try to get this right here. Shift down 3. Okay, so I'm going to draw a quick little graph right here to show you kind of what it does. Shifts left 4, so I'm going 1, 2, 3, 4. Shifts down 3. That tells you where you're going to start your graph. So I'm going to start my graph left 4 down 3 right down here. Usually I would go right 1 up 1 to right there, but because that 1/2 is there, I'm just going to go right 1 up a half. So I'm just going up a half to about right there. Connect those dots, blah, blah, blah. And remember, if it's a square root graph, it's half of a sideways parabola. And that's all I got for you today. That was I'm sorry about that last slide. It wasn't the best, but we did get it right at the end, so that's all that matters. We'll work on these in class tomorrow, the even and the odd, and a few more shifts and shrinks and stretches and reflections and stuff like that. So transformations, I should say. See you then.